The title of our first talk is Exploring the Advice Networks of Agricultural Producers from a Spatially Explicit Social-Ecological Systems Perspective. Good, we got a short title on that. Fantastic. This research presentation is being done by a group of authors that have applied for our postdoctoral Fellowship in Sustainability Science Award last year. So Marilyne Jollineau, professor from the Department of Geography here at Brock and a center member, and myself were the applicants on this grant, and Dr. Julia Baird was the postdoctoral fellow. Julie's been with the center as a postdoc for over 3 years. Good that I have kept track of that. And she has a diverse research portfolio, but primarily has focused on social network analysis. And most of the context that her work occurs is socio-ecological systems. This particular project, and one of the reasons that Marilyne and I were so excited to work with Julia on it, is it connects one of my past, from way back, interest in agriculture with Marilyne's expertise in geospatial technologies. And of course, Julia brought all that together and married these two research interests in a new and innovative way. So I'm going to exit and let the two of them do the presentation, but I will rejoin again during question period.
Thanks, Ryan. So I'll start, but Marilyne and I are going to kind of switch back and forth between us depending on whose perspective we need to explain some of the things that happened in this study. So I also have an interest in agricultural research. My background is actually in crop and soil science, and at least up until my master's degree. And so I was keen to apply social network analysis in an agricultural setting, and a big part of that was related to some work I did in my PhD, where I was looking at perceptions of different policies for enhancing water quality on agricultural landscapes. I was trying to understand some of the patterns that were emerging, and I thought social network analysis could potentially be a really useful tool for that sort of a question. And so out of thinking about that over a few years, eventually emerged this opportunity to collaborate with Ryan and Marilyne, and I'm thrilled to be able to provide some results from that work today. So for those of you who are familiar with agricultural landscapes, we know that it has the potential to have a major impact on water quality, and the study site is no exception. So this photo was actually taken in the study site, and you can see some interesting occurrences along the waterway with washed out edges of the waterway, cattle pathways right into the water, and resulting impacts are sedimentation that happens in the water from the soil. We get E. coli and other goodies in the water from manure from the cattle. And so agriculture can have multiple impacts on water quality in these landscapes, and is a significant threat to the sustainability of agriculture and to the landscape. The tricky thing about agricultural pollution is that much of it is non-point source. So that means that we can't necessarily identify exactly where these pollutants are entering the waterway and in what concentration. So there's complex entry paths and uncertain causal relationships, and these non-point source yes, pollutants, thank you, really create a conundrum for policymakers, because we don't know exactly where things are happening, to what extent, and so how do we encourage a reduction in water pollution when we can't exactly target where they're happening. So in Canada and in many other places around the world, there's been a significant push for voluntary measures to try to deal with some of these non-point source situations. And one of the major ways that that's happened in Canada is through the use of beneficial management practices. And these are practices that have been developed through research They are intended to not induce any negative economic impact on agricultural producers, but they don't necessarily have an economic benefit to them either. They are intended to reduce the impacts of agricultural pollution on water bodies and on other aspects of the environment. And so this has been one of the main ways that that Canada has tried to reduce water quality, or improve water quality and reduce water pollution. They're also used as an indicator of the sustainability of agriculture. So the uptake of beneficial management practices is linked to a reduction in water quality, or reduction in erosion, or reduction in the input of water pollutants into waterways. Now, the relationship between adopting a practice and the actual outcomes of that practice are, of course, not entirely clearly linked, because there are many mitigating factors. So things like climate can have a major impact on water quality outside of the uptake of a beneficial management practice, and there are many other factors as well. But it is used as an indicator. And basically, uptake of beneficial management practices has remained steady at around 40%. So 40% of agricultural producers have implemented some beneficial management practices. And that's okay, but we're still seeing major impacts from agriculture on water. So we continue to devote research to understanding reasons and causes of beneficial management practice uptake in Canada. How can we improve uptake? It's also been studied internationally, so there are a range of studies looking at factors that influence decision-making of agricultural producers, and who's more likely, what are the attributes of those people that are more likely. And one of the things that came out of this research is that accessibility of information is really important for making those decisions. There are other factors too, but that was one of the main ones. But the pathways by which agricultural producers actually gain information is not entirely clear. And the influence of social networks on agricultural producers and their decision to use BMPs has also not been studied in any significant way in developed countries. So, what has been done? There's been a few studies. Marnie Isaac at the University of Toronto is one person who's done a few of them in a developing country context. And then there's been a few others in other places, in forestry and in the English countryside. So they're related to agriculture, but may not be as applicable to a Canadian context as we might like. What they find is that a peer-to-peer advice network is really important for influencing decision-making around land management practices. The other thing that was found is that core groups or organizations also link farmers with information about these practices. So there's two kind of main groups that can really influence decision-making. And we were curious to know how that plays out in Canada. The spatial arrangements of these social networks is really kind of an interesting area that hasn't been studied, but we think may be very important. Agricultural areas tend to be fairly sparsely populated. Access to information isn't always easy for some farmers in comparison to those that are in more kind of semi-urban settings. And so is there a spatial relationship around these social networks? And this has been studied again by Marnie in a developing country context, but not in a developed country context. So that leads to some questions. So first of all, who do farmers rely on for advice in our context? And second, what is the impact of these advisors on the landscape. So who's having an influence and what kind of an influence are they having? And third, can we use this to actually start to improve beneficial management practice adoption? And ultimately the goal is to use this to improve water quality and agricultural sustainability. So we have 3 objectives. This was an exploratory study. It was used to identify sources of information and advice used by agricultural producers in land management decisions, first of all. Second, to understand the structure of advice networks, and I will talk about network and network structures in a second. And third is to link the advice network spatially and incorporate water quality data. So ultimately what we want to do with this work is to connect the social and the ecological in a meaningful way. So the methods that we used. We chose a subwatershed in southern Alberta. I'm not going to say which one due to the terms of our research ethics protocol. But there were 68 landowners in the watershed. We contacted each and every one of them. 16 agreed to participate, so the response rate is fairly low. We asked them to identify the land parcels that they own and that they farm. In addition, we asked them a series of questions about the agricultural activities that they engage in, some of their reasons for adopting practices, what practices they adopt, and with whom they communicate regarding land management decisions, as well as how often and whether they contact that individual or that individual is actually initiating contact with them. So we did this, yes, through a face-to-face survey, and actually Katrina Crevens was our research assistant on this project, and she was the one who went to Alberta and did the data collection. So if you have questions about doing a social network survey, she'd be a good person to talk to. The other thing that I should mention is that concurrent to our research, Alberta Agriculture was also conducting some research in the said watershed, and they very graciously provided us with water quality data. So we were able to access that ecological data from Alberta Agriculture. So I'm going to talk about social network analysis as a method very quickly, and then I'm going to turn it over to Marilyne to talk about the geospatial aspects of the work. So social network analysis, for those of you who haven't heard me talk before, it provides measures and visuals to show connections among entities. They can be people in events, they can be people in organizations. There's a range of different ways that you can approach this. From an ecological perspective, you can also use a network analysis to link different aspects of the environment in terms of how they may be connected. So this is used in a lot of different fields, but we're using it in a social context. Basically all it is 2 nodes, so let's say 2 people that are connected by a tie. And that tie indicates that they communicate in some way or they have some connection to one another. The arrow indicates directionality. So if we want to know who initiates that communication and who receives it, or if it's reciprocal, the arrows can come in very handy in that. So the other thing that I'll say about social network analysis before I turn it over to Marilyne is that when we create diagrams just of a social network, they're arranged in space in a way that those that are most similar to one another appear closest to one another in a diagram. But they are not arranged geospatially. So when we start to incorporate geospatial methods, that gives us an opportunity to look at these social networks from an entirely different perspective.
Yep. Thank you, Julia. So on the geospatial technology front, some people are familiar with those and some people aren't. So we use that term, some people use the term geomatics as an umbrella term that covers various tools that we use. So Geographic Information Systems, or GIS, is one of them that was used in this study. Or remote sensing, satellite imaging or airborne imaging of the Earth's surface, and measuring reflectance from the surface. And then others use global positioning systems or GPS. So we didn't use GPS here. I came into the study after the survey had been conducted. But this gave us a great opportunity to link this network to real world geographic coordinates. And one great advantage of using GIS is that we can then visualize relationships and really how those relationships kind of manifest themselves in the patterns that we see in the landscape. So together with a student who's an intern at the time, he's now a research assistant on this project, Josh Valente, we actually digitized all of these data that we had from the survey. So that meant inputting into somewhat of a table format the attribute data around these different land managers, from their BMP use, BMP adoption, to their sort of agricultural practices on the landscape. And then what we did is we took the maps that were used by Katrina in her survey, and we actually tied those to real world coordinates. So she had the landowner identify their property boundaries, and then we actually took that information and mapped it out. Why did we do that? So then we could add to that other geospatial data sets, like the monitoring stations that are used by Alberta Agriculture, right? Those are water quality monitoring stations. We could also then map out the main stream in that sub-watershed and tributaries that run throughout it, right? In addition to that, we created what we're calling a 3D social network, which is not something you always see in publications. It's rather new. And I would really attribute that to Julia's brilliance that way. She said, hey, you know, what if we could do this? And Ryan had seen it in some other studies as well, I believe. And so we thought, sure, let's try it. So we started to construct that 3D social network, where we had limited experience about social networks. We had more expertise on the geospatial side. So we really needed to work together and collaborate, and that's why you see us both sharing the floor today. So what we did, a term that we use in GIS is buffering. Buffering is basically a measure that we use to calculate proximity. So we'll talk a little bit about how things unfold on the landscape relative to where a landowner's property is with respect to the main stem of the watershed and the tributaries, and, you know, the distance out from that. And then we also used what we call interpolation techniques, which are simply techniques that allow us to take point measurements and spread them across the landscape, right? So that we could then clip those to the streams and tributaries in the study setting. So here's what that looks like. We don't have the boundary, and we're trying to avoid identifying the location, and hopefully I won't actually say it at any point, but that's why you might feel like there's scant detail here when it comes to cartographic principles, but we do have a scale to give you some sense of the size. It's about, I believe, 145 kilometers squared or something, roughly. I would just note that we're actually looking at an area of very high elevation here, right? Follow the main stem here down to the outlet labeled 1 there. That's the first water quality monitoring station that's identified there. So you're going from higher elevation in the south, right, to the north. So everything is draining in that direction, right? We have superimposed onto that these landowner property boundaries. There were 37 in total, and we had 16 respondents. And what we're looking at here is water quality mapped for a 3-year period, and this is nutrient water quality index that we're looking at. So it's basically taking into account most of the nutrients that we find coming off of these landscapes like phosphorus, nitrogen, E. coli, etc., can be measured. So we did that. And we also looked at some other sort of descriptive statistics about the demographics of these landowners. So average age being sort of late 50s into the 60s, predominantly male. Many are producing livestock, so the livestock is especially in this part, and then as we move down into the sort of outlet, we get into more of grain production, barley, wheats, oats, etc. So just keep that in mind. This is an area that receives a lot of precipitation during snowmelt and heavy rainfall events. You might imagine that we have quite dramatic changes in water quality. So when we present some of those results, bear that in mind, that individual events can fluctuate quite dramatically from streams that contain absolutely no water to streams that have quite a bit of water moving through the landscape. So hence our use of averages in that sense. Okay.
Great. So, in terms of the social network and the sources of information that our respondents relied on for making decisions about land management practices, we divided it into kind of 4 main advisor types. So the first is local actors who we consider to be their peers, so other family members, neighbors, other farmers outside the watershed, that sort of thing. Regional experts, so these could be individuals that work for municipalities. They call them municipal fieldmen. I know that that's not really a politically correct term to use, but it's the term that they use. So we kept it. Regional workers for provincial agencies, as well as for federal agencies. Oftentimes these agencies or organizations may be provincial or national in nature, but the people that work with farmers live and work regionally. So we consider them to be the regional experts. And then we also had printed materials, newsletters and farm magazines, and finally other businesses. And then there was a significant proportion of respondents who indicated that they didn't talk to anybody about their land management practices, which we found kind of interesting. As Katrina smiles. So you can see that the proportion of respondents who connect with regional experts, although that's a fairly broad description of a group, that most respondents indicated that they were communicating with some sort of an expert. So this is our social network only, so this isn't a spatially explicit network, but rather just a social one. The respondents are the red nodes, and the gray nodes are those that they rely on for information. So you can see our 4 isolated individuals up top. And then we can see a fairly kind of loosely connected network of respondents and advisors or advisory, materials or options that they rely on, that they're connected to. But I think what really struck me first when we created this was how loosely connected they are. And how often these connections are not reciprocal. So we asked them specifically, do you both communicate with one another, or is this kind of a one-way communication, and if so, which way is that communication happening? So a few things I wanted to note here. We were interested, beyond just kind of what this social network looked like, we were interested in the role of these different groups. So how important are regional advisors? How important is that peer-to-peer network? And how important is, there's a sub-watershed group that exists within this watershed that was created by Alberta Agriculture as a way to communicate information, and their intention was that once they stepped away from this group, it would continue to run and they would continue to provide them with information, but it would basically be like a peer-to-peer opportunity for farmers to connect within the watershed. And if I can find it here, here it is, right up there. So you can see it's not having a very significant impact on the respondents that we talked to, and in fact, they indicated that this sub-watershed communicates with them, but they don't actually go to this watershed group for information themselves. So that was kind of interesting. In terms of the regional advisors, those that were connected to regional advisors, whether they were municipal workers or provincial or national level advisors, those people that were connected to regional advisors generally had a greater number and diversity of beneficial management practices that they were implementing than those who were not connected to regional advisors. And they also tended to have a larger and more diverse network than those who were not connected to regional advisors, as well as a greater concern for water quality than those who were not connected to regional advisors. So some interesting patterns emerging there. Finally, we were also interested in that peer-to-peer network that I mentioned that would seem to be very important in when there was work being done elsewhere. So we were very curious about what that looked like here. So how are respondents actually connected to one another? Well, they're connected to some of their peers. You can see there's some, they mentioned some neighbors, but they don't say who. But when we look at respondents' connections to one another, we see that they are not connected at all. There are 0 connections. Nobody mentioned anyone else who participated in this study. And so this took an interesting turn, or led to an interesting turn in the work, because we were really interested in what that peer-to-peer network looked like, especially spatially. But that just wasn't possible given the data set that we had. So we employed some other techniques, and Marilyne's going to talk about some of those now.
Okay, so as we indicated in our objectives, the purpose was, of course, to look at the social network piece, and then to try and map onto that, okay, spatially, what do we see happening here, using GIS to really visualize that. Tables and graphs are nice, but it's also nice to see then how that actually plays out across a landscape. So bear with us for a moment. It will become more obvious. You're looking at 3 layers here of data within a GIS, and 3 corresponding legends that go with each individual layer. One, the top one, representing the social network piece, right? So actually showing that spatially, where you'll see those regional actors represented as those nodes colored red, yellow, blue, and purple, right? So those hover above the landscape because, as Julia suggested, they're not really embedded in the landscape in the way the landowners are. Similarly, you have a slightly lower level there, those gray nodes are local actors, so family, neighbors, etc., who also may not be embedded in the landscape, but of course have some influence over what we see happening or practices that are adopted in the landscape. And as Julia mentioned, we found that regional actors really play quite a significant role in the adoption of these BMPs. So just to explain how that sort of looks, those purple nodes, for example, that sub-watershed group is shown as purple here, and they have some influence, if you will, on those purple land parcels that you see, right? And when you see different combinations of color outside of those first top 4 categories, the red, sort of orangey, purple, and blue, then you have those combinations of multiple regional actors that people are engaged with. Then on the middle layer is where we start seeing some pretty interesting things happening in the landscape, where the middle layer which is a little bit harder to look at. So orient yourself perhaps to this L shape that's on the second layer, the BMP layer, and that sort of matches up with this one here, and then down on the third layer, that's that parcel of land. So on the second layer, we have a range of activities, from adopting perhaps one practice to a couple different practices. And while there are more practices or BMPs that are used in this watershed, we focused on 3 that are quite important for agricultural land use practices, right? Grazing management, erosion control, and manure management. And what we found, as Julia suggested, and we can use perhaps this, these properties here, is that those who had not adopted any BMPs tended to also not have any connections, either locally or regionally. And the more connectedness they had, the more BMPs they might have used. So some statistics for you, that respondents connected to regional advisors were more likely to use erosion control, and you can see it's coupled with either manure management or grazing management here in these 2 categories, than those that were not. So 70% roughly versus 17%. Quite a big difference. Again, I want to remind you that livestock, there was sort of livestock production predominated the landscape in the upper part of the watershed. These are also slightly steeper slopes here, so that might make a little bit of sense versus the topography down here that's a little bit flatter, say like 5 to 9% roughly slope. The other interesting piece of this is then what I talked about with this proximity, right? Distance out from that major waterway. So here, this is again oriented north. That outlet is right here. This is the upper part of the watershed, and the main stem is this here. So we could actually look at those that have fields adjacent to a waterway, those that were within 100 to 200 meters of the waterway, and those beyond it. And Julia mentioned those beyond it tended to have very little concern about water quality, for example. 50% of those that were adjacent, had adjacent fields to a waterway, were cited a reason for BMP adoption was concern for water quality, and 100% of the folks in around the 100 to 200 meter range from that major waterway were cited concerns about water quality in terms of their adoption of BMPs. So some interesting results that we see here that match what we found in the social network analysis. Just a couple other interesting pieces of, or statistics rather, that generally, as I mentioned, no BMPs were typically linked with poor water quality in the watershed. Erosion control occurred in 61% of the fields adjacent to a water body, and 2/3 of those at the 100 to 200 meter distance, but not further away. That manure management occurred in 25% of water adjacent fields, and 2/3 of that occurred in the 100 to 200 meter range, but again, not further away. And we didn't really see a spatial trend in terms of grazing management. So there was also a trend in the reasons for implementing BMPs. So again, about 50% concerned with water quality were right beside a waterway, versus those further away did not cite that as a concern, which is something that needs to be explored further, I think. Some other interesting findings was that the type of advisor also showed no connection to, closer to the water body versus further away. So,
sorry, do you want me to switch or no?
No,
okay.
Yeah, go ahead.
Okay, sorry.
So what we've done more recently, and this is very recent, in fact, Josh sent me this graphic last evening, so, but he's very keen to participate, and so we also started to tease apart that nutrient water quality index to get at more specific measures of water quality like total phosphorus, total nitrogen, and even E. coli. And those sort of, I don't want to say worst offenders, but those folks who tended not to adopt any BMPs were connected with poor water quality, as I mentioned. And as you move through the watershed, you see, and that's typical of many watersheds, you see that the water quality degrades as you get closer to the outlet or the mouth. So here, what you're looking at, and these aren't yet geographically arranged, so you're looking at the stations roughly organized closest to the outlet to furthest away, but not entirely. So a couple new stations were added in more recent past. So we were looking at those data as well. But the end result of this is that we see again, where you see station 21 is where we have that block of no connections and no BMPs adopted. So while we think that we need to explore that finding further, we see that there's some evidence to suggest that BMPs and their adoption may be linked somehow to the water quality measurements that we're getting at these various monitoring stations.
So a few preliminary conclusions and I guess a few next steps that we're going to take, or that we're in the midst of taking. So first of all, watershed groups and the peer-to-peer communication that we thought would be very important in this watershed did not appear to be as important as it was in other studies. But regional extension individuals were really key to BMP uptake, and also we're beginning to make some connections to water quality as well, which is pretty exciting. And finally, we noticed that there were some spatial trends. So one of the examples that Marilyne talked about was that landowners with land not adjacent to waterways may be less concerned about water quality, may just not even think about it in their decision making for their land. And so some of the next steps that come out of this work are to begin to look at that connection. If you think back to that 3D visual, making the connection all the way from the very top of that 3D visual to the bottom. So connecting the social network with water quality and what that connection looks like. So that's the plan. So we have a few acknowledgements to make. First of all, the Environmental Sustainability Research Center for funding this opportunity to collaborate, which has been really great, as well as SHRC. And research assistance from Katrina and also from Josh. I'd like to acknowledge the respondents that were willing to talk to us as well. I think they deserve some acknowledgement here too, as well as the in-kind support from Alberta Agriculture. And thank you all for being here and listening.